If A, B, C are the sides of a right triangle where C is the hypotenuse. So we have the C over here. Prove that the radius R of the circle which touches the side of the triangle is given by. So we have the radius and this is touching the sides of the triangle. So basically we are looking at what? Yes, these are tangents and these are your radius. So all these angles are 90 degree. Let me use the lighter layer. This is 90, this is 90 and this is 90. And this is all radius. So this length and this length are equal. We have to prove that R is equal to that particular expression. So this has to do with the fact that which property should we use? Yes, we have to make use of the tangent from our external point. So where are the external points? We have we have point, capital letter point C, capital letter point A. Let me use some other color. I think, is that visible? No, right? Okay, let me do this. Point C, point A and point B are your external point. Have a look. And to that we have the, let me show this. AF is one tangent. From the same external point we have AE as the other external point. Sorry, tangent. It has to be external. It is tangent. Then we have CE and CD are other tangents. Then we have, which color should I use? I guess this. BC looks the same now. BC, not BC, sorry, BF and BD are another set of tangents from another external point. Why am I doing this? We know that their lengths will be equal. Is it not? Just a second. Okay, this is better, right? It's a bit more highlighted. All these lengths are equal, right? And we have angle C to be 90 degree, by the way, because C is the hypotenuse. So this is 90 degree. Now, how can we go about doing this? Well, very first thing is that we have three 90 degrees in a quadrilateral and the adjacent sides are equal. So this is a square. So all the sides are equal to, yes, R. So we have this to be R and this to be R. So using this fact, we have to continue. So let's think about it. This is R, this is R. This entire length, right, is B, but we have AE. Okay. So this is R. This entire length is B, by the way. So this part of the section of the length will be what? Yes, it will be B minus R. And so this in a similar manner, okay, that we can't do anything, but this we can tell to be equal to what? Yes, A minus R. And this is RR. Okay, so what else do we have? We have AF to be equal to AE. So somehow we can get an expression for C, or we can call this as X. Make it a bit convenient to think. So if I call this as X, so the other remaining part will be what? Yes, quite simple. It will be C minus X. Agree? Right? So this will help us somehow get the answer for R. So let's start off with the diagram itself. We need to make the diagram as part of our answer. Then we have prove that, right? So we have a prove statement to be written to prove actually. We have angle, not angle, I think R is equal to A plus B minus C divided by 2. And now we have the proof. Okay, first thing we'll start off with, consider a quadrilateral OECD. So we'll talk about OE being equal to OD as they are radius Then we have, what else? We have angle OEC is equal to angle ODC. Both are equal to 90 degree. Okay, for this the reason is radius is perpendicular to the tangent at the point of contact. And then we have, what else do we have? Angle OC, not OC, sorry, BCA. BCA is also equal to 90. Why? Because it's the angle opposite to the hypotenuse. Angle opposite to the hypotenuse. Is it not? They given C to be the hypotenuse. We need to explain it reason. We can't just jump to conclusion. Therefore, ODCE is an square, is a square, not an square, it's a square. Reason, a pair of adjacent sides are equal. Agree? Adjacent sides are equal and three angles are equal to 90 degree. Okay, so we have this to be a square. Therefore, DC, which is equal to CE, will be equal to OE, and all of them are equal to R. And now we have the following. BE is not BE, AE. First thing is we'll get an expression for AE, which is equal to AC minus EC, which is equal to B minus R. Okay guys, let me take the diagram. It's easier that way. If not, we have to move back and forth, and you guys know that will give us a headache, me and you guys. Just a second, let me arrange all of this. So where were we? Right, I got an expression for AE. Then we'll write an expression for BD as well. So BD is equal to BC minus DC, which is equal to A minus R. Then we will call, let AF be equal to X. Therefore, we have BF, which is equal to BA minus FA. Again, you can pause and have a look as and when I write C minus X. So if you want to pause, please pause and have a look, match it if I have written things right. Even actually I am verifying. Okay, looks correct. And now, with all of this, what can I do? We can get the expression for R. How? Simple. So we know that BD is equal to BF. Why? Tangents from the same external point. And so we have C minus X is equal to A minus R. Right? So I'll get an expression for X. Okay, I'm transposing in all of that. Or let me do the other way around so that you guys are not confused. C minus A plus R is equal to X. Okay. And then we have, what else? Yeah. Oh yeah, I could have gone that way actually. AF is equal to AE. Right? The same reasoning, you don't have to explain yourself. So we have X being equal to B minus R. So from equation 1 and 2, what can we tell? We're almost done, by the way. From this 2, what can we tell? So from 1 and 2. So what we have here is B minus R is equal to C minus A plus R. A bit of rearranging and we are done. Right? So I'm transposing R over there. We have R plus R, which is equal to 2R. And we have B plus A minus C. And we have almost the answer. Therefore, R is equal to B plus A minus C divided by 2. Hence proved. That's it. Okay, so that would be your answer.